नोटिफिकेशन आली की असं सांग. Live. I'm on the live. I think screen sharing is working properly. Okay. So there is a screen sharing. Fine. So so I have been going through the machine learning algorithms. As you know, machine learning is what you can say very much booming trend in the market. And in the machine learning, you can do lot many things, lot many job opportunities are there in the machine learning and the data science. By considering all these facts, I have started working with the machine learning. What you can say after before 6 months ago, rigorously, and something I was trying whole day that I would like to explain you, and that algorithm is called as SVM. If you have heard this, SVM is nothing but the support vector machines. So there are many algorithms actually: linear regression, logistic regression, then SVM, support vector machines, and every algorithm has its own significance. So what is the support vector machine? If you want to get the mathematical background, or if you want to get the mathematical proofs of that, you can go to the YouTube and just search MIT OpenCourseWare and support vector machines. You would be getting in-depth knowledge of the support vector machine with the mathematical background. So I'm not going to explain over here mathematical proofs, but what I'm going to explain today, or what I have implemented from the morning, is nothing but the scikit-learn implementation of the SVM. So I have implemented what you can say SVM algorithm by means of scikit-learn. Scikit-learn has given you lot many things actually, and you just need to get some Python scripts and that you need to run, and your SVM will work automatically. Okay, that's what I'm going to explain you today. So let's start with that. So I have explained you, if you want to get the mathematical proofs, go with the this thing here. You will get in detail. I'm not going to explain all these things now. If you can see, so actually this is nothing but the Google Colab, one of the software or one of the website provided by the Google to work with the TensorFlow. TensorFlow is another thing, and the scikit-learn is another thing. So I'll explain that thing in some other videos. That it is not the right time to talk about what do you mean by scikit-learn, when do you use the scikit-learn, and when do you use the what you can say TensorFlow. That would be the another story. Let's focus on the little algorithm that is nothing but the SVM, support vector machines, right? So if you go to first thing, in the first cell I have loaded the data, then created the data mapping class, then prepared the data, right? Then something called as bag of words, I'll explain in a moment, and training the data, then what you can say predicting the values. That's what I did over here. So let me start this with little intro of the SVM. If you see this, a support vector machine SVM is a discriminative classifier formally defined by the hyperplanes, separating by the hyperplane. So if you see this in between line, this line is called as the hyperplane. Well, if you see these faint lines, these two faint lines are called as the support vectors. These are called as the vectors, right? And the what you can say, so if you see, there is a red data set and there is a blue data set. So these are the data sets. So what I'm going to implement today is that you would be having a movie reviews. There are some movie reviews available on the Kaggle that I have downloaded, and I'm going to load it over here. So movie reviews, we need to classify them as positive movie review or the negative movie review. So you can consider the red ones are the negative and the blue ones are the positive. So positive movie reviews and the negative movie reviews, we are going to separate it. So what definition says is that, in the other words, the given label training data, which is nothing but the supervised learning, we are giving data and we are expecting some output, which is nothing but the supervised. So we know that the supervised learning, unsupervised learning, and the reinforcement learning, these are the things in the artificial intelligence or the ML. The algorithm outputs an optimal hyperplane which categorize the new examples. In the two-dimensional space, this hyperplane is line dividing. They are talking about this line dividing a plane in the two parts where each class lay in either side. So you can consider these are the negative reviews, or these are the positive reviews. For the detailed explanation of the support vector machines and the mathematical proof, I'll again recommend go to the YouTube and read it on the MIT course, open courseware, right? But this is a little bit definition of the SVM, support vector machine, right? Then how do you load the movie reviews first? We'll see that. What I did, I have taken all those reviews in one of my Git repository. If you want that, just copy this, and if you go here and a moment, I would like to copy this. You can paste it here. You'd be getting that CSV file. CSV is nothing but the comma separated file. If you have used this file before, that is nothing but what the comma separated file is. And first thing, I have imported something called as pandas. Now what do you mean by the pandas? It is again one of the open source library from the Python, which is nothing but the panel data, is nothing but the pandas. So what it does, it gives you a tremendous data, or it gives you the utility, or it gives you many tools to operate on the data, like querying, like sorting, filtering, many things pandas give you. So if you go here, I have imported the pandas. Remember that whenever you go with the Google collabs, right, all the machine learning related environment is given to you. Can you see they allocate actually one machine to you, which is having some RAM and disk? This disk space is nothing but your drive disk, and they allocate some RAM, right? Even you can define the runtime over here. Go here, change runtime type, and here if you can see, if you want GPU, default one is CPU, GPU, or the TPU, right? If you have a heavy data set, you may opt for the TPU or the GPU. Runtime is a Python, right? Python 3. I'm canceling it presently. We don't need to worry about that. But remember that if I go here and pd dot read CSV is one of the method which pandas gives you, where you can provide a link. And once you provide a link, it will give you all the data. See, I'll go here and just run the code. So all the data would be getting imported. Just go here, and here you can have df df, or at the end, what I will do, df dot head, first 5 rows it will give you. Can you see the output of the df dot head is this, uh, rows which are first 5 rows for the head. You can see, even you can have something called as tail. Well, all these methods you will get in the pandas, and these methods are really important, right? And you need to have a hands-on experience on the pandas. Pandas will help you a lot. See, pandas and numpy are the two libraries that you need to know. What I'm saying, pandas and the numpy. Well, what I did over here, first I have imported all the data in the pandas, then df.sample. Remember that if you see here, or if you go to the CSV, you will find that more than 67,000 records are there. And what happens if you have more than 67,000 records? At the time of training, it will take too much time. It will take too much load. When you train the data, that is nothing but the 67 records on the instance given by the Google, it will take a huge load. So what we did, randomly we have selected the 10,000 records only. So it will not take a load at the time of, what you can say, training the data. That's why I have, what you can say, that's why I have reduced the data set to the 10,000 record. But actually, that is, what you can say, if I go here, print and df dot shape, let me run. Can you see 64,000 records are there? If you can see here, but out of them we are just using the 10,000. So if you know, or if you have used the shape method, it will give you number of rows and number of columns. You have 64,000 rows and the 6 columns. That's how shape method will work. Okay, this is the example I have given, and some operations I have did over here. Operations like this, you can see pos underscore df is equals to, so what it will give you, it will give you, can you see the filtering, filter all that records, right? Or here you can say pos dot ilock. Ilock is one of the property that will give you the zeroth record or zeroth row and the text of that zeroth row, and that's why you'll get output something like this over here, right? One of the review put by a user, and that review you will get over here, right? So this part is just for the data cleaning. Cleaning up of the data can be done over here, like, right? Cleansing of the data can be done over here. So loaded the data, then cleansing up of the records has been done over here. Presently data is not that ugly, but many times you get the data, you might need to clean it. Okay, here is the output. Now here what we did, we have created the data class, a review class. When you say review, review would be having the review text and the review type. See one thing, all the data scientists or as far as I have seen, the people who are working on the ML, or they are working on the as a role data scientist, they do not go with, what you can say, object oriented principles, right? But it's a well recommended strategy that you should go with the, what you can say, object oriented principles in the Python. You should follow, no matter you are developing some web application in the Python using Django, or you are writing the machine learning script, you have to go with the, what you can say, object oriented principle, right, for maintaining. So let me collapse these things, loading data and data class we have discussed. So if you are familiar with the Python, remember that if you want to start with the machine learning, or if you want to start as a data scientist, right, one thing for sure you need to know, that is nothing but the Python. You should be master at the Python. So remember that, what do you mean by underscore underscore init, then self, and other things. I'll not discuss all these things in this video. For that I would be recording a detailed series on the Python, what Python you need to know for the machine learning. Preparing the data. Now see, I have taken the reviews array over here, right? I have taken what? Reviews array. And df stands for the data frame. We have used the df over here, a variable we have used, which stores all the data. And here if you can see, there is a iterator, who iterates on the 10,000 records. And if you can see, this is an array, and into the array we are go on appending the review object. Here we have created the review object, so we are trying to access the text. If you remember, if you remember df.shape, and here you can say just print df and run it. Can you see there is a column name, fold id, cv tag, html id, sent id, and can you see text is your actual review text, and tag is nothing but the pos, positive or the negative. Can you see negative, negative, here positive, positive. So here is a text, here is a tag, here is a text, here is a tag. Tag is nothing but the review type, that is a positive or the negative. So we are going to train a model by using algorithm called as support vector machines, right? We are going to train a model by using the support vector machines and having the 10,000 records on it, which where you would be having a review and its type, review and its type. Well, under the preparation, first we have created the review array, and this review array we are going to use throughout. Now here if you can see, from scikitlearn dot model underscore selection, you can import train and test split. Here you'll get the detailed documentation of that. If you can see why people use this, so there is one function called as train underscore test underscore split. This is one of the function, right? So what it says, split the arrays or the matrices into the random train and the test subsets. If you can see, training comma testing is equals to train test split. Here you are passing this reviews array, right? Test size, see, if you out of the 100%, 30% you have allocated for the testing, and the random state we have given the 0. So if you go here, if int random state is a seed used by the random generator number, if random state instance random state is a random number generator, if none, random number generator is a random state and used by the np random, it is for generating some random state internally. Okay, now if I run this code, let me run this as well. Let me run this as well. Let me comment these two lines. Can you see the training data length is 45,000 and the testing data length is, what you can say, 19,000. 45,000 and the 19,000. Okay, so let me remove this df presently, and let me run all this sequentially first. Okay, now it's correct. So earlier it was taking the 64,000 as a record, but we have sampled it to the 10,000 one, right? So here if you can see, training length is 7,000 and testing length is 3,000. Do you remember we have given the testing data size is a 30% here? Okay, now there is something called as bag of words. Means you need to convert your text words into the numbers, and one of the algorithm used for that is nothing but the bag of words. So here is the explanation. If this is a sentence, the red dog, can you see there will be the columns, the red dog cat eats food. Now see, if here is the becomes one, red becomes one, dog becomes one, there is no cat in this, that's why it is, there is no cat in this sentence, that's why it is 0. There is no eat in this sentence, it becomes 0. So it finds all the unique words and it make as a column names. So what it does, it finds all the words inside your training data and make the column names in that way. Now let's have example: cat eats dog. Now see, in this sentence there is no the, that's why it becomes zero. There is no red, that's why it becomes zero. So dog is available, so it becomes one. Cat is available, it becomes one. Eats is available, it becomes one. But there is no food, and your complete data set need to be converted into this kind of matrix, and this algorithm is called as bag of words. For that, for the bag of words, we are going to use sklearn feature extraction text. If you can see, sklearn feature extraction text and the count vectorizer convert a collection of a text documents to a matrix of token counts. If you can see this, this implementation produces a sparse representation of the counts using the scipy sparse, whatever internally what they have used, they have given over here, but convert the collection of a text document to matrix of the token counts. And this we have used over here. If you can see, vectorizer is equals to the count vectorizer, training x. Can you see here, first we have split the data, and then what I did, train x, into the train x, all what you can say review text would be there. Into the train y, remember that on the y axis you need positive or the negative, and on the x axis, means horizontal axis, you would be needing all the review texts. So all the review text would be on the x-axis, and on the y-axis there would be what you can say positive and the negative targets. Here you would be having. Okay. Now if you can see, the feature columns are these. The feature columns are nothing but these columns: the, red, food. If you can see, these are that columns. These many columns in our total data sets are available, and below that there are some numbers, right? So creating a vectors is nothing but that. If you can see, fit underscore transform, there is one method they have given. And if you see the method fit underscore transform here, learn the vocabulary dictionary and return the term document matrix. Learn the vocabulary dictionary and return the term document matrix. So fit underscore transform, and transform just converts to the matrix. If you can see, the transform the document to the term matrix. Term matrix is nothing but this thing, converting all this converting this term to the matrix. That's what it is doing internally. Okay, so this is nothing but the bag of words. So I'm just giving you the overview of the algorithm SVM, support vector machines, right? It's not the detail, just overview. Now actually training, how do you train the data? If you want to train the data, can you see, from sklearn you need to import the SVM. From sklearn you need to import the SVM. Now the variable svm underscore classifier is equals to svm dot svc. Svc is one of the class, and that is nothing but the support vector classifier. And here you are giving the kernel is equals to linear. Okay, now what do you mean by kernel is equals to linear? If you look at this diagram clearly says that the data sets are going to be separated by the hyperplane, right? Means there is a line between two data sets. So this is a negative data set red, and blue one is a positive data set. But sometimes instead of having the line, there can be a polynomial. Means data is not separated by the straight line, that can be separated by some, what you can say, another polynomial. That is another implementation of the SVM, right? This is a linear implementation if data is separated by the linear line and data is separated by the polynomial. Well, if you see here, fit So whatever vector you have created for the x, that you are passing, and the target, that is nothing but the positive and the negative. What you are passing, positive or the negative, and the vectors. We know what do you mean by vectors. Vectors is nothing but the bag of word and this array we are passing over here. Right, let me run it, and you can let me run it. So it will take a little time, depends on your internet and depends on your data set. If you have very much heavy data set, it will take too much time. Yeah, now if you can see, the implementation has been done. If you can see, implementation or the training has been done, you can get the output, and then the prediction. Now what I want to do, the testing vectors, I want to predict on the 50. So on the vectors you need to predict, just run it, and you can say whatever matrix is there for the 15th, what you can say, review, that is nothing but of the positive. For your understanding, what I have taken, someone has kept this review, I have created my review as one variable, and into that variable array, and into that array a single string is there. If you can read that string, that we have vectorized over here, vectorizer dot transform my underscore review, and then we have predicted that. Again, it is saying that this is the positive review, right? If you need the negative review, we'll check it. Tag is exactly equals to neg. So let me try to run it. Can you see, this is one of the negative review someone has posted. Let's get, and let me try what our model predicts. What our model predicts for this. Oh, that is missing over here, single quote. Can you see, it is giving you the negative review, right? So these reviews are little bit in the, what you can say, a lengthier reviews. So if you, and the reviews are nothing but the comments or the commentaries on the movie, that's why these are the too longer. If you put something like I don't like the movie, still it might give you the positive, because that kind of data set we don't have. We have something commentary kind of data set. So if you go here, movie review dot csv, you can see the reviews of 100 to 200 words. It's not like that I don't like movie and I like the movie. It's not like that. This is a commentary on the movie, and that you are passing. And from that, you have prepared one model, and that model is saying that the person is talking about in positive way, or the person is talking of in the negative way. So this is a little implementation. People call it as NLP or the sentiment analysis as well, but this is the very much fundamental and very much basic kind of thing we have implemented, or I have implemented. Well, I'm coming with the detailed series on the machine learning using Python, where I would be covering all the algorithms, scikit-learn, pandas, numpy, Python, and you can say TensorFlow, in detail TensorFlow. Remember that this thing is not that easy. You need, what you can say, too much time to understand the things, because maths is there, then Python is there, then understanding of algorithms is there, and lot many things are there. You need little time, right? So don't worry, but machine learning has too much scope in near future. Well, it's too late now. Thank you and good night.